Let's do this. Daily intake. Analyzing categorical data. This grouping things by anything other than numerical values, you're grouping them by categories. Categories by learning how to use tools such as bar graphs, Venn diagrams, and two-way tables will expand your abilities to see patterns and relationships in categorical data. So where are we? This is all finished. Categorical data example. Two-way table, categorical data example. Okay, let's do this.
Lucio wants to test whether playing violent video games makes people more violent. He asks his friends whether they play violent video games and whether they have been in a fight in the last month. He recorded the results in the table shown below. Fill in the table to show the fraction of each group of students who have been in a fight. Then decide whether there is an association between violent video games and getting in a fight amongst Lucio's friends. So let's see what they're doing here. So students who play video games, fractions who have been in a fight, fraction who haven't. Students who don't play violent video games, fraction who have been in a fight, fraction who haven't. So let's answer the first part of this. Students who play violent video games. So let's look at those students. So the students who play violent video games, it looks like Ellen plays violent video games. Actually, let me just focus on the data that we care about. So Ellen, so let's look at all the people who play violent video games. So let's see, this column is violent video games, so we have a yes here. So actually we have both of these right over here. And then we have down here, and then that's all of them. There's 1, 2, 3, 4, 5 people who play violent video games. Now what fraction of them have been in a fight? Well, it looks like 1 out of the 5 have been in a fight. The rest of them have not been in a fight. So we could say 1/5. Let's just write that down. So 1/5 have been in a fight. 1/5 have been in a fight. Fraction who haven't, 4/5. So that's all these other no's. They play violent video games, but they haven't been in a fight. 1, 2, 3, 4, 4/5. So students who don't play violent video games, well, that's everyone else. And let's see how many data points that is. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's a total of 15 students. And how many of them have been in a fight? So let's see, we have 1, and then let's see, 1 and 2 and 3. So 3 out of the 15 have been in a fight. So 3 out of 15 is the same thing as 1 out of 5. Those are equivalent fractions. And then the fraction who haven't, well, that's just going to be everyone else. That's going to be 12 out of 15 or 4 out of 5. 4 out of 5. So based on Lucio's data, and this wasn't a huge sample size. Obviously, he only found 5 kids who were playing violent video games, and one of them had gotten into a fight. So this isn't a super rigorous study, but at least based on his data, if we're trying to decide whether there's an association between violent games and getting into a fight amongst Lucio's friends, it doesn't seem like there is. It seems like relatively, whether or not they play violent video games or not, 1/5 of them have been in a fight in the last month. So it really doesn't seem any difference. If this number was, I don't know, 4/5 or 5/5 or all of them, then I would say, hey, even with Lucio's fairly small sample, I would say, hey, maybe there is some type of a strong association between playing violent video games and fighting. But in here, you really don't see any difference.
What do you say?
So it really doesn't seem any difference. If this number was, I don't know, 4/5 or 5/5 or, all of them, then I would say, hey, even with Lucio's fairly small sample, I would say, hey, maybe there is some type of a strong association between playing violent video games and fighting. But here, you really don't see any difference.
In science, you have to ask the question before getting the data. You're not allowed to interpret the data as you go. You have to ask the question and answer it. So you're not allowed to see this data and then interpret it the way you want it. You have to ask a question before it. Or at least that's what I understood from my conversation with Claude. That in science you have to answer the question. You have to ask the question first and then either prove it or refute it. The hypothesis, it's called the hypothesis. Okay. Take over this side. Okay. Next.
The relative frequency table below shows statistics from a study about the relationship between the amount of time a person spends using a computer before bed and the amount that a person sleeps each night. For computer use, each participant was classified as minimal, moderate, or extreme. So let's look at the frequency table below. So let's see, that's the frequency. The relative frequency table below shows statistics from a study about the relationship between the amount of time a person spends using a computer before bed and the amount that a person sleeps each night. For computer use, each participant was classified as minimal, moderate, or extreme. So let's look at the frequency table below. So let's see, that's the frequency table, and let's see, there's 3 categories of computer time, just like they told us: minimal, moderate, and extreme. This is before they go to bed or at night. And then they have the 3 categories of how much they're sleeping: 5 or few hours per night, 5 to 7 hours per night, or 7 or more hours. Okay, so that's fair enough. So let's see what they want us to do. So they tell us, suppose there were 17 people in the study who were both in moderate computer users and got 5 to 7 hours of sleep. So moderate, 5 to 7. So this category right over here, there were 17 people in this category over here. And just to mark that, I copied and pasted this chart onto my scratch pad so I can write on it. So this group, they're telling us this group, and my pen is really acting up. I don't understand what's going on. This group right over here, there are 17 people. So that group right over there is 17 people. Now what are they asking us? They're saying, how many people in the study were both extreme computer users and got 5 to 7 hours of sleep, round to the nearest whole number? So extreme and got 5 to 7. Get my scratch pad out. So they're saying how many people are in this bucket. In this bucket right over here. I think I have to replace my pen tablet or something. I don't know why it's getting all splotchy like this. So how would we think about this? There's 17 people in this group. How many people are in this group?
This is actually math at its core. Column in total 100. 17 here, but it's out of the 17 or 30, 10. Doesn't add up. That's 74%. Total is the total. 10% Okay, so row, column. Okay, total is 10%. Total out of the 100 is 10%. Row, column. What does that mean? Row is over here. Huh? Column and total. Row total.
Well,
Interesting.
they tell us that 17 is 34% of the row total. So I guess you could say 17 is 34.3% of the moderate computer users. Or you could say that 17 is 30% of the people who slept 5 to 7 hours each night. Or you could say 17 is 10% of the total number of people. So let's just go with that. We could figure out the total number of people. So 10%, actually, let me write it this way. So 10% of
What's 11.7%? If 17 is 10%, which means and 11.7 is how many? $19.89, but that's not possible. This whole we can't, okay, it's about the columns. It's 30. Does it say how many people in the survey? I'm interested to see his way.
Of the total, 10% of total is going to be equal to 17, or that the total, just divide both sides by 10%, is equal to 17 divided by 10%, which is the same thing as 17 over 0.1, which of course is equal to 170. So the total is 170, and they tell us that extreme computer users represent extreme computer users who sleep 5 to 7 hours per night represent 11.7% of the total. So to answer their question of how many people were extreme computer users who sleep 5 to 7 hours per night, it's 11.7% of 170. So let's go back over here. So we actually have a little calculator tool here. So it's 11.7%, which is 0.117 times 170. Times 170 is, and let me make sure that you can see what I'm doing by scrolling over a little bit, times 170 is equal to 19.89. So if we're rounding to the nearest whole, that's going to be 20 people. 20 people.
Is that it?
And then they are going to ask us some questions. They say, does the table show evidence of an association between being a minimal computer user and getting 7 hours of sleep or more? So let's just look at the chart. So an association between being a minimal computer user and getting 7 hours of sleep or more. So it looks like minimal computer users, so these are the minimal computer users who get 7 or more hours of sleep. And there's a couple of ways to read this. So you could say that 51% of minimal computer users get 7 or more hours of sleep. You could say that of the people who get 7 or more hours of sleep, 55% are minimal computer users. And of course, this one just says that minimal computer users who get 7 or more hours of sleep represent 18.3% of all of the people who were surveyed. So let's look at the choices. And before I even look at the choices, let's see if there's an association. It does look like, if you look at minimal computer users, it looks like a small percentage, only 16%, get 5 or few hours. A higher percentage gets 5 to 7 hours. And 51%, the highest percentage, gets 7 or more. So it looks like for minimal computer users, it looks like the distribution is definitely weighted towards getting more sleep. And for example, if we look at the extreme computer users, it's the opposite trend. 47% have 5 or few hours per night, 33% 5 to 7 hours, and then only 19% get 7 or more. And it looks like the moderate is someplace in between. So just looking at this, just looking at each of these rows, it looks like there's a trend where if you use a computer for less time, you're more likely to have more sleep. And likewise, if you use a computer more, you're more likely to have less sleep. Another way to think about it, when you look at the people who are getting 7 or more hours of sleep, a majority of them are minimal computer users. And there's 3 categories. So for 55% to be minimal computer users, it really does feel like the minimal computer users are more, they're definitely more disproportionately representing the people who are getting 7, or disproportionately represented in this category of 7 or more hours of sleep. And you see that the extreme computer users in this category, they represent only 20% of this category. So it does look like there is an association between minimal computer use and getting 7 or more hours of sleep. But let's look at the actual choices they give us. Does the table show evidence of an association between a minimal computer user and getting 7 hours of sleep or more? So yes, because 35.1% are extreme computer users and 29.1% of people are moderate. Well, I go with the yes, but this doesn't seem to really back up the claim. This is just giving us some kind of random data about the percentage that are extreme computer users or moderate computer users. No, well, I already explained why I go with yes, that there does seem to be a trend, and I don't even believe what the statement is, because the total column percentages are essentially equal. We see that the total column, that the column percentages are not equal for the various, for people who are getting 7 hours or more of sleep. So we see that right over here, 55, 25, 20. So I won't go with that one either. Yes, because 51% of minimal computer users get 7 or more hours of sleep, and only 33% of all computer users get 7 or more hours. Yeah, I mean, that seems pretty good. 51% of minimal computer users get 7 or more hours of sleep, and only 33% of all computer users get 7 or more hours of sleep. So that looks like a pretty good explanation. So I'll check that, but let's just review all of them. No, well, I already said I think it's yes, but because the total percentage of extreme users who get 5 to 7 hours of sleep is the same as the total percentage of moderate computer users who get 5 to 7 hours of sleep. So that doesn't really meet, it's not touching on the point that we're looking for. Yes, because 55% of people who get 7 or more hours of minimal computer users, and only 35% of all people are minimal computer users. Actually, I'll go with this as well. Oh yeah, this is a multi-select here, so I could select that one as well. So this one we're looking at so here we looked at the percentage of minimal computer users who get 7 hours of sleep, and we saw that percentage is higher than for the whole population. Here we're looking at the people who get 7 or more hours of sleep, and we're saying, wow, 55% of them are minimal computer 55% of them are minimal computer users, even though only 35% of all the people are minimal computer users. So I would go with both of these. And so let us check our answer, and we got it right.
Hence the check mark, because there is more than one answer. Okay, let's do some exercises and call it for the day. This is the usual routine. What's happening? Fucking slow internet. Practice, let's go. Justin's dad claims that taking piano lessons will help Justin get into an Ivy League school one day. Justin decides to try to prove his dad wrong by interviewing a randomly selected sample of college-educated adults. Justin asks them whether they attended an Ivy League school and also whether they took piano lessons as a child. The relative frequency table below shows his results. Justin interviewed 88 people who did not attend an Ivy school. The odds. Okay. How many adults in Justin's survey took piano lessons and attended an Ivy League school? He said 88 people who did not attend an Ivy school. Non-Ivy school, total 91%. 91%. Non-Ivy school. What does that mean? So 91% non-Ivy League. Am I correct? 91% non-Ivy school. Okay. Out of the 88 equal 91.7. The next is the total of the Ivy school is 8.3. 8.3. So what's an 8.3 equal to? $7.96. So that's 8. So the people who attended Ivy school IV8 was the question again. How many adults in Justin survey took piano lessons and attended an Ivy League school? Piano lessons 2.1. 2.1%. Look at this, 6.25, meaning out of the 100, all of it. This is 8.3, but out of the 8.3, which is 8 people, am I correct? Which is 8 people, it's not 2.1% out of the 88.3. It's 1.1% out of the whole 100. Wait, 2.1% out of the 100 also. So 2.1 plus 6. That's 8, 9. Let's say 9. 9 and 23. No way. I would say that this 2.1% is out of the 100. Because if you add these together, it's gonna make it to 8.3. So it's out of the 88 people. 2.1 out of the 88 people. Which means at 88, 2.1, 2 people, I would say. Round to the nearest whole number. Let's say 2. Say 2. Does the table show evidence of an association between taking piano lessons and attending an Ivy League school? Choose all answers that apply. 6 people didn't take, so no. Looking for no because the total percentage of people piano lessons is less than the total percentage of people who did not take piano lessons. But that's not. No, because 8.3% of people who took piano lessons attended an Ivy school. 8.3% of all people Ivy school. Wrong. 25% of people who attended an Ivy League school took piano lessons. 25% of all people took piano lessons. What does that mean? What does that mean? 25. But it's not. Oh, 25%. That's actually correct. Ivy School, 25% of the people who attended Ivy School, which make us look at our previous to make it sure that it's 2 out of the 8. Out of the 8, only multiplied by 2.5. 2. It's 2. So it's 2. 25% of the Ivy League. So, and 25% of them piano lessons. I would say this one, but I don't know how to. I don't think this is no, because 25% of people who attended an Ivy League school took piano lessons. That's correct. And 25% of all people took piano lessons. So 25% of the 25%. I'd go with this. Still don't know. This is, you see, the linguistics of statistics is very hard. But this is no, because 8.3% of people who took piano lessons attended an Ivy League school. Uh, no, that's not correct. It's 25%. So this is correct. 8.3 of all people attended an Ivy League school. This is not correct, no, because the total percentage of people who took piano lessons, the percentage of people who took piano lessons is less. Is less than the total percentage who not take piano lessons, but this is this is correct, but it doesn't imply that there is no relation here. Let's check. Not quite. Give it another try. Problem is here. Yes, because attended an Ivy outing at only taking piano lessons at only 2.1 and took piano lessons and attended an Ivy school. Does the table show evidence of an association between taking piano lessons and attending an Ivy League school? No. Yes, because 25% of people who attended an Ivy League school took piano lessons. The 8.3 of people who took piano lessons attended an Ivy League school. The yes is not correct. Piano lessons, only 2.1% attended Ivy school. Oh my god. Ivy League, column 8.3. 8.3 of the piano lessons were taken of the piano 8.3%. Wait, how is this even possible? Piano lessons, raw 25, raw percent. Ivy League, this is the raw. Piano lessons 25, no piano lessons 75, 100, raw. Column, this one, 8.3 piano lessons. 8.3 piano lessons and 20 and 91.7 piano lessons non-Ivy school, non-Ivy League school. The whole total of the piano lessons who attended Ivy school is 2.1%, and 8.3 who attended 8.3 all the people who attended Ivy school. But on the piano lessons, there's only 2.1% of all people again, of all people. Let's look at the total: 2, 22, 68, 6. Let's say no, because the total percentage of people who took piano lessons is less than the total percentage of people who did not take piano lessons. What does that has to do with Ivy? It's not this. Must be this. Ah, there is two. I could choose two. No, because 8.3% of people who took piano lessons attended an Ivy League school. And 8.3% of all people attended an Ivy League school. How's that? 8.3. How's that? I don't know. How's that relevant? But how's that? How's this relevant? I don't understand. How's this explain the question? Who took piano lessons attended an IB school? What does this say? Only 8.3% of people who took piano lessons attended an Ivy League school, and 8.3% of all people attended an Ivy League school. Of all people attended an Ivy League school. What does that mean? I don't think so. So the answer must be yes. So it refuted. 25% of people who attended an Ivy League school took piano lessons. 25% of all people took piano lessons. 25% of all people took piano lessons. 25% of people who attended Ivy school took piano lessons. Is it? No? 25% of people at an Ivy school took piano lessons. That's wrong. Is it? Yeah, but that's right. Piano lessons. Two. Are you gonna say three? I don't think so. Does the table show evidence of an association in taking piano lessons and attending? Does that mean association? Means linking, a link between taking a piano lesson. Perhaps yes, because 6.25% of people attended an Ivy League school, attended an Ivy League school without taking piano lessons. So, is he talking about the people in general or the people who attended an Ivy League school without taking a piano? But only 2.1% of people took piano lessons. Took piano lessons. What does that mean? This means that not taking a piano lessons means who attended an Ivy, an Ivy League school took piano lessons. Only 8.3 of people who took piano lessons attended an Ivy League school. I'll take this. Man, let's check this out. Seriously. This means don't take a piano lessons. I don't get this. What does this mean? I don't think so. Okay, that's it. We'll show a step. How's the table show? So they can be honest in Ivy's. Choose all answers that apply. It shows evidence. It says don't take piano lessons and go to Ivy school. Doesn't show. No. Does it? Are you for real? Let's check this out. Let's start by finding the total number. Are you saying that 2 is my problem? What's that? And the survey. 21.7 in the table. Is that 91? Another view. Then the Ivy school. There's 80. Didn't go to an Ivy League school. So 88 equal 0.9217 total number of people. What does that mean? 96. There were 88 people who didn't go to an Ivy school league, which is 88 equal 9.7. Okay. So how many people left? 8.2. 96. 8.2. 88. Okay, 96 minus 88 is 8 people. Adults in Justin's. Yeah, that's 8 people. Oh yeah. Oh yeah. Yeah. Yeah, 7.96 is 8 people. Justin Survey took piano lessons and attended an Ivy League school. Okay, so that's 2 out of the 8. 2 out of the 8. So yeah, there are 8 left, and 2 of them took 25% of the 8. Which means 2. Are you saying there are 3? There are 3. That's 8 people. But out of the 100, there's only 2.1. Only 2.1. So 96. 2.1 out of 96. Two point one out of the 96. Let's use that calculator. Show calculator. 0.21 in 96. 20. What do you mean? 0.0.1. 96. 2. Get another hint. 2. Fuck you. Fucker. The number of people I took piano lessons is 2. My answer is 2, right? Right, 2. So this is number. Get another hint. Piano lessons attended an Ivy League school, and 8.3% of all people in the survey attended an Ivy League school. Knowledge that someone took piano lessons does not give us any information about whether or not they attended an Ivy school. This shows that there is no association. No. So I said no. Okay. Knowledge that someone does not give us. Okay. 25% of people in the survey who attended an Ivy League school took piano lessons. 25% of all people in the survey took piano lessons. Knowledge that someone attended an Ivy League school does not give us any information about whether or not they took piano. This also shows there is no association. What are you talking about? So this one and this one, is that it? Two people took piano lessons and attended an Ivy school. Only the following are correct. No, because, no, because. So this was not correct. This choice was not correct. Let's start by finding the total number of people in the survey. Right. This two, I have chosen this two. What are you talking about? And you give me wrong. Good thing that I have a video on. I'll go back to this and see. Okay, Jonathan heard a news report that eating a gluten-free diet makes a person more likely to have a positive outlook. Jonathan heard a news report that eating a gluten-free diet makes a person more likely to have a positive outlook on life. Here, the news report that eating gluten-free diet makes a person more likely to have a positive outlook on life. This sounded appealing, but he felt he should investigate the claim before drastically changing his diet. Jonathan asked 128 people at his school whether they ate gluten-free and then determined whether they are positive or negative people. A positive outlook on life. Jonathan found that there was no association between eating gluten-free and having a positive outlook. With this knowledge, fill in the missing joint frequencies below. There was no association. Okay, so the gluten-free positive total, gluten-free total 12, no gluten-free 116 out of 128. Or total, on the other hand, is 464 and 64. '64, which means 50% were positive people. 50% were positive people and 50% were negative people. Either ways. So 50%. So what can we say? So what can we say is 0.012 multiplied by 64 is positive gluten free. Column in total. 128 people. So this is 128 and this is 12. So out of the 28, we should okay, 128 128 minus 116 is 12. So 12 right, 128 100 12 equal what? So 12 is 100 128. What is this? 12 100. Is this? What is this? Plus? No, this one. 128 is 9.375. So 9.375 multiplied by 64 over 100, 6 people. So here is 6, and here is 6, because this says 12, and 116, 46 minus 6 is 58, and 46 minus 6 is 58. Am I correct? And 58 and 58, 58 plus 58, 116. Gonna check it. Let's go like this. One 16 over 100, 128, 116, 100, 90%, 90%, 0.625, so 90%. So that's 906 64 57 point, so it's 58. I'd go with this. Check. Next question. Chris wonders whether the planes that fly over his house follow any sort of pattern. For 2 months, he records whether each plane. Chris wonders to a relative as this questions as well. Chris wonders whether the planes that fly over his house follow any sort of pattern. For 2 months, he records whether each plane he sees follows a north-south route or an east-west route. An east-west route. He also records the day of the week that he sees each plane. Unfortunately, Chris dropped his data in the mud and can't read all of his numbers. The absolute and relative frequency tables below show the numbers that Chris is able to read. Can you help him figure out the rest? So I got X here. What else? Row. So I got this, and I got this X. Here is one thing missing. 48, 84.56, and 33. That doesn't add up. Column. This is column. So this is not a one thing. Absolutely. Fill in the missing values for each table. This is not row. This one 100 minus 67.14 will get the X. Columning, of course, this is not, but this is a row. So this, okay, so this is only the X is missing. Only the X is missing because this is a row. Column in total is column in total, and this is row total. So, okay. The only missing one is X. Fill in the missing values from each table. North, south. Monday to Thursday. North, south. North, south. Monday to Thursday. North, south. Monday to Thursday. It's 48%. Raw total is 148. So 77% out of that 148. X's X is of course 100 minus 76.14, which is 23.86. Okay, what else? What are we having? We have 77%, 77.77 .7770 multiplied by 148, that's 115, and then we got from Friday 184 minus 115, 148 minus 115, 33, and then we got east-west, the row is 88, or we can just say 136 minus 115. You could say 136 minus 115 equal 21, and then 100 minus 33, 100 minus 33 equal 67. So let's add them up. 67 plus 21 plus 115 plus 33, 236, which is what we got here. So let's check them. Is it this? Okay, next question. At a popular rock climbing site in Yosemite National Park, a randomly selected sample of 200 climbers are asked whether they have ever had a climbing accident and whether they are certified climbers. Whether they have ever had a climbing accident and whether they are certified climbers. The results are shown below. Suppose you are searching for a climbing partner at Yosemite and you meet Garrick, Molly, and Ryan. Garrick just got in a bad climbing accident. Molly has a certification card attached to her harness, and you know nothing about Ryan. Based on the frequency table below, calculate the following probabilities round to the nearest hundredth of a percent. Has had an accident, 2, not certified, 6. 8, has never had an accident, 192. Certified, 183. 138. Has never had an accident, 138. Certified, and 54 uncertified. 54 uncertified, 192. Column in total 140, 60, 200. Row total 60. Probability that Garrick is certified. For a climbing partner at Yosemite. Okay. Garrick just got in a bad climbing accident. Molly has a certification card, and you know nothing about Ryan. Probability that Garrick is certified. So we got out of the people who has an accident. He has an accident, right? Garrick Garrick just got in a bad climbing accident. Okay, so out of 8, 2 out of 8 equal, okay, 2 out of 8, 25%. 25%. He has an accident. Probability that Garrett is certified is 25%. Probability that Molly has not had an accident. She said Molly has a certification card attached to her harness, so she's certified and she not had an accident. No. 138 out of 140, 98%, huh? Has not had an accident. $98. It says what? Near its 100th of a percent. Okay, let's multiply it by 100. لا. Delete. Is there a delete? 100 equal 98.57, which is 99. Probability that Ryan is both certified and has never had an accident. That Ryan is both certified and has never had an accident. So out of the 2022, he is certified and never had an accident. 138 over 200, 96%, 69%. Check. Probability that Ryan is both certified, he's here, certified, and has never had an accident, 138 out of the whole total. So this is 69. Probability that Garrick is certified, he has an accident, of course. Garrick just got in a bad climbing accident, so he had an accident 2%, 2 out of 100. Probability that Garrick is certified, not 25. It's 2 out of 200. Multiplied by 100. 1. It's 1%. Just had an accident. That Molly has not had an accident. Probability that Molly has not had an accident. Molly is certified, so she has not had 138 out of 200. 138 out of 200. 69 again. Has not had. All we know. Molly has certification, so she is certified, but she is 69 again. I'll go with this. Motherfucker. Probability that Garrick is certified. 2 out of 200. Did he has an accident? Garrett. Eric just had a bad climbing, so he has an accident. He has an accident, and he is 2 out of 200, which is 1%. See that Molly has not had an accident. She is certified, so 138 over 200. 138 over 200 is 969. See that Ryan is both certified and has never had an accident. Certified and has never had an accident. 69. What does that mean? Okay. 200 climbers. Okay. Was your session for climbing one with Garrick, Molly, and Ryan. Garrick just got in a bad climbing accident. Molly has certification card attached to her harness. And you know nothing about Ryan. Bad. He had an accident, and he is certified. 2 out of 200 is 1%. Probability that Molly has not had an accident. Molly is certified. She has never had an accident. That's 138 out of 200. Probability that Ryan both certified here, and has never had an accident here. 138 out of 200. Again, 69. Is this so? Where am I going wrong with this? 2 out of 8 has had an accident. Has not. But she is certified. So 138 out of 200. Another 138 out of 192. I know about her. She is certified, though did she claim those certification after she had an accident? So she never had an accident. That could be 138 over 192 if she claimed her certification after she had an accident. But this has never had an accident. 138 has never has had an accident. Probability that Garrick is certified. He has an accident. He had an accident. Probability that he is certified. 1%. Right. Out of the people who has had an accident, only 2 certified. But we know that he has an accident. So, is he a certified one? 2 out of 8? That's a different thing. I don't get this. He just has an accident. Just got in a bad climbing accident. What's harness mean? What does harness mean? Set of straps and fittings designed to hold, control, secure a person, animal, or object. Okay. Just give me show a step. Garrick has been excellent. There were 8 climbers in the sample that had experienced an accident. Only 2 of them were certified. So 20%, 25%. Okay. So this, my first answer was correct. This is certified. Based on what we know. So Molly, based on what we know, that she is certified. She is certified. Molly has not had an accident. She is certified. 138 of 140. 138 out of 140. 98.5. 57. 98.57. So that's 99. Okay, show step. Point 57. The point. Why are you saying round to the nearest hundredth of a person? Okay, I got it wrong. 98.57. Two out of four correct. Try it again. I don't think so. I don't think so. Two-way relative frequency table. You see here and there. Got them all wrong. Course mastery 4%. Try again. Let's try. Jonathan and then heard a news report that eating a gluten-free makes a person more likely to. Oh, mother. Again, the same questions. Now that there was no association between eating. Fill in the missings. 6 we said. 6. And 58. 58. How many people in this study got 5 fewer hours of sleep? And this one, 5 or fewer hours. It says the relative frequency table summarizes. There were 42 extreme computer users in the study. Here, 42, 16%. 35, actually. Extreme, this is extreme. 35.1. So 42. Summarize the result. There were 42 extreme computer users in the study, which is 35.1. New people in this study got 5 or fewer hours of sleep. So here, 33.3. So we're gonna say is, where's the calculator? Show me the calculator. We got 44 equal 35.1. What would 33 equal to? So 33.3 multiplied by 42 over 35.1. 39 is there. Round to the nearest whole number. 40. 40, I'd say. Does the table show evidence of an association between extreme computer use and getting 5 or fewer hours of sleep? So extreme 5 or fewer, 16%. 16%. 16%. 16%. And here 10%. 5.8%. Yes, it does. Yes, it does. Am I correct? No, actually. In computer using getting 5 fewer hours. Answer that apply. Actually, all the people who are getting 5 or fewer are 33.3. And 16% of that goes to extreme. So does that show? I think yeah. Actually 50%. 50%. 32.17. So 50, yeah, it does show. Yes, because 50% of people who get 5 or fewer hours are extreme computer users. 35.1 of all people are extreme computer users. Yes. No, yes, because 47% of extreme computer users are not correct. 35. Out of that 35, out of that's 100. 47.6% out of the 35. What are we saying? 5, there is 47%. Five, only 33% of all people get 5 fewer hours. Is that correct? Are extreme computer users. Is that correct? They are. And 29.1 of people are moderate. This is not relevant. This is not relevant. So let's go with this. 33% by 3 of all people get. I don't know about this. 50% of people who get 5 are extreme computer. 35. Only 35.1 of all people are extreme. So I don't know what the other statement is actually referring to. What does that mean? That out of the I don't understand. People are extreme computer users. 30. Okay, correct, but what's that has to do with the 50%? Gives you 16%, okay. Okay, so what's this saying? 3 of all people get 5. 33. 33. Out of them is 50%. Right. 16. Only 33% of all people I don't understand. This shows nothing. Irrelevant. Problem is, once you get one wrong, okay, you get it right. Not a popular rock climbing site in Yosemite. This we just solved, so 2 out of 8. Rob, Andrew, this is new. 200 climbers. Suppose you are searching for a climbing partner at Yosemite and you meet Rob, Andrew, and Sarah. Rob thinks himself as a free spirit. Wait, this is totally different. Look at sample of 200 are asked whether they have ever had a climbing accident and whether they are certified. Okay, Rob thinks of himself as a free spirit. He climbs without any certification. No certification for Rob. Andrew is hoping to continue his lifelong streak of never having climbing. You don't know anything about Sarah. So the probability that Rob has had an accident. What it says here. Andrew is hoping to continue his lifelong streak of never having a climb. Rob thinks he climbs without any certification. Probability that Rob had an accident. Has had an accident 2 out of 8. 25. Really, probability that Andrew is certified. Probability that Andrew is certified. Andrew, what does Andrew is hoping to continue his lifelong streak of never having a climbing accident. He has never had a climbing accident. $140 out of 200. Is this separate from this? Because before it was separate. Suppose you are searching for climb. You meet Rob, Andrew, and Sarah. Rob thinks of himself as a free spirit. He climbs without any certification. Okay, Rob has no certification. This is Rob. Has no certification. No certification. Probability that Rob has an accident. 6 out of 60 actually. 6 out of 60. That Rob has had an accident. 6 out of 60. 6 out of 60. 1%. Okay, so again, the Rob has had an accident. He is not certified though. We know that he's not certified. So 1%. Thinks of it as a free spirit. He climbs without any certification. He is not certified. He has an accident. 6 out of 60. 6 out of 60. Not certified people. Kids. Has had an accident. Okay, probability that Andrew is certified. Andrew is hoping to continue his lifelong streak of never have a climbing accident. Has never had an accident. Certified 138 out of 192. 138 out of 192. 171, 71.87. Okay, probability that Sarah is certified. Sarah, we don't know anything about her, so she is 1%. 1%. Because she's out of the 200. We know nothing about her. Rob, how do you get to 1%? Rob has had an accident. He's a free spirit, not certified. 6 out of 60. How did it become 6 out of 60? Rob, wait, Rob. Rob, think as he climbs without any certification. He's not certified. 6 out of 60. 6 out of 60 is 1. We already hit a wall here. So either I'm reading probability that Sarah is certified. Sarah is out of the 200. We know nothing about her, so she's 1%. Is there a problem here? Andrew is certified. Andrew is hoping to continue his lifelong streak of never having a climbing accident. So he has never had a climbing accident. Probability is certified 130, 183 out of 192. 138 out of 192. What do you mean? 188? Okay. Chicken. 22. 21.875. Talking about the nearest hundredth percent. 88. Is no certified. Show. Rob has experienced an accident. 1%. Get it. 71.88. 0.88. So this is the problem. The 1. 2 out of 8. Certified. 140 out of 200. There's no way. Because they both are certified. 40 out of 200. Sarah is certified. Sarah is certified. They are 2 certified. And what do you mean? I don't know anything about her. She's 2 out of 200. What do you mean? No information. There were 200 total. 140. 140, that's what I'm getting. 140 out of 200. 70%. 70. No? $71. Okay. What are you talking about? 71.88. 1. 70%. It's the same. What's 4? I had them all. What's the 4th question? Where is the 4th question? I don't see any question. 1, 2, 3. %. Zero. Okay, next question. Tyler is bored. If we get this right, we might get a bonus question. God damn it. I'm not gonna redo this ever again. Tyler is bored in history class, so he is starting at the ceiling tiles. Tyler is bored in history class, so he is staring at the ceiling tiles. He notices that some tiles are perfect squares. So he is staring at the ceiling tiles. He notices that some tiles are perfect squares, while others are long rectangles. He also notices that some of the tiles are bright white, while others are off-white. He makes a detailed notes on how often each of these tiles occurs. Tragically, Tyler crumpled up his notes. The teacher looked in his direction, and now he can't read all the numbers. The absolute and relative frequency tables below show the numbers that Tyler is able to read. Can you help him figure out where's the X? So, first of all, it's a 100 minus 96.7, 69. 100 minus 69.7, 30.3. Concentration is bright white, off-white 38, row total, column in total 48. Off-white he got it all, so column in total, rectangle. Does it say here anything about it? No. So what it does actually say 48 square. That's a 65% 0.75. The 48 is 65% out of. Okay, so the rest. So we got so how many? 34. So it's say 34.25 multiplied by 48 over 65.75, 25, that's a 25 rectangle over there, minus 10, 15. Okay, 25 and 48 plus 30, so 73. Let's see. 10, 25 and 25. That's 50 and 23. That's 73. 25 and 15. 30, 40. 40 and 33, 73. Okay, check. Bonus question. That's because we got one wrong. Chris wonders whether the planes that fly. Okay. Route east. Chris dropped. Okay. 100. Again. 100 minus 76.14 equal 23.86. Okay, southeast. Now it gives us the number. Monday to Thursday. We got north-south, Monday to Thursday are 77% out of 100, which is the raw total. 77. So it says 777 0 divided by 148, 114, 115, 115, 136. That's 136. Don't think 115. Still got a coding. Go to 21. Go 148. 48 minus 115. 33. 88. 8 minus 21. 67. Let's add them all together. Plus 33 plus 21 plus 67, 188. That's not correct. 115 plus 38, 67, 21, 236. Correct. Oh my god. Now I see. Now we corrected this. Course mastery 5%. I think this is out. Total point represents the progress you've made on this course. Master every skill to collect the available mastery points. So this is out of the. This is 5% out of the course of statistics and probability. Two-way relative frequency table. I think we'll. This is if I knew there's more exercises. Not repeated that. Two-way relative frequency tables and associations. Two-way relative frequency tables shows us percentages rather than counts. I'm gonna pause here, guys. I think I'm gonna finish this tomorrow because I still have coding, or after the coding, if there's much time. So let's stop it here and I'll get back to you later. See yous. Bye bye.